So today we're going to have a bit of a squiz at Travis and network adjustments in TBC. So my name's Peter May. I'm one of the technical consultants at UPG in Sydney. I was a land surveyor for 14 years before about 6 months ago moving over to UPG and performing these wonderful feats of presentations and training. So if you've got any questions as we sort of go along, please place them into the IM box, and I will open up the floor at the end for anybody to ask any questions if you've got anything. Also at the end, my email address and the contact numbers will be there. So if you've got any questions, current projects you're working on and things like that you want some help with, please get in contact, and we'll try and give you a bit of help. Alrighty, so let's dive into the Travis and network adjustments. So Trimble Business Centre being Trimble's flagship office software for geospatial, so for surveyors and also construction people. We will look at this more from a geospatial perspective. Obviously, this is very geospatial, but it's again just looking at it in the sense of a Travis. We're not going to look at baseline processing. If we run another session on GPS baseline processing, we'll also run in that network adjustment package as well, just to sort of see how that sort of flows through the workflow from baseline processing and then into the network adjustments. So just to kick off, the Travis adjustments, we'll have a bit of a squeeze at how TBC can do it. TBC can import the data, it can edit the data, and it can create and adjust Travises in the Office software. Now, it'll give you an adjustment report at the end of it, telling you obviously your positional misclose, your angular misclose, and then all the other ratios and everything like that. That can be then saved as part of your QA process for if you're a land surveyor and you've got to provide evidence to show that you're completing your accuracies of your surveys to a certain tolerance, like we do here in New South Wales. We have to keep those records, and I'm sure there's a lot of others keep those records so that we know that 100% that everything's within a certain tolerance and ratio. Now, the way TBC looks at Travis adjustments, you obviously will have to start and end on a known station, or at least you'll have to have some connection to a start and an end station. But in a typical Travis, you'll start on one point, you'll traverse through, and then you'll most likely then finish on that same point. So in the example on the right hand side, we would set up at station 1, we'd backsite station 3, we then traverse through 5, going anti-clockwise to 6, connection back to 1. Now that will give us our positional misclose, but obviously we want angular, so we then reset back on 1, site to 6, and then site to 3 as a foresight, and then turn that final angle. Now everything, the way it looks at the intermediate stations, there are all the others that are related to it, and you can be linked in and have an intermediate station and then connect to an end station, but that'll be where you'll be able to calculate your distance misclose, or if you, for instance, end on a known point that's not occupied, you'll obviously be only able to get an angular misclose. But ideally, we really like to keep it as the conventional Travis. It makes it nice and easy for everybody, and it's better for the program to be able to calculate everything you want. You can obviously change up your Travis and set up on 1, backsite 3, site 6 and 5. So turn that angle. So turn all 3 at once, and then traverse through, finish on 6, backsite to 1, and have that as your closing line. But ideally, you'd want to have a closing line. Now the network adjustment. This is the least squares side of TBC and looking at Travises and adjustments. So the network adjustment will perform that least squares adjustment of a network of observations, and it could be GNSS baselines, could be Travis, could be RTK, it could be some level data in there, and you can do it all in one hit. So you don't have to do little bits and pieces here and there. You can do everything in one hit. If you were doing a Travis adjustment, you can only do one loop. And then from there, you'd have to go off and do another loop, and then you have another loop. And so you'd have all these little loops everywhere with potential miscloses and accuracies. But A network adjustment looks at everything in a whole, all the observations to all the connections, and being able to come up with a better solution. Now, the purpose of the adjustment is to estimate and remove the random errors that we might have, provide a single solution, with all the data instead of, having, as I said, those little loops. Minimize the corrections to the observations, detect the blunders, so looking at how your ratios and your standardized residuals fall out at the end, and generate some statistical information that you can then store as a bit of a reference for later. So going back and giving a little bit of a rundown on what we would sort of be looking at for a network adjustment. Ideally, we're looking for a reference factor of 1 and a chi-squared test pass value. If it sort of doesn't go through that, and you for instance get a value that's less than 1, we've sort of underestimated the accuracies, and we might need to come back through and sort of tweak our figures, our standard deviations, and work out what potentially we could have done. So for instance, we may have surveyed better than we're currently quoting, and you, for instance, get a value less than 1. But then on the other side, if you've surveyed worse, you'll get a value of 1, and that could be where you've either overstated your accuracies. For instance, you said you 1 second when it's actually a 5-second jigger, or for instance, you've blown it out to 10 seconds because you weren't sighting it correctly and your instrument wasn't in adjustment, and all those other sorts of bits and bobs. At the same time, as it could be that you've got an error in there, which could be that pole height was wrong, or you had the wrong prism constant, or something like that, or again, there's not enough redundancy, and you might need to add some other observations in there to sort of help bulk it out, to help it get across the line. So chi-square is the overall statistical test of the network. It looks at the sum of the weighted squares of the residuals, the degrees of freedom, and also the critical percentage as it meets against the 95% confidence interval. I'll show you all that in the back end of the software and sort of where to see all that in a second. A lot of it's set up in your project settings. So if you've got a good template already set up for your projects, you could have a template that is for your network adjustments that's set up all your constraints and everything. Or, for instance, you could have one that's for everything, and for detail surveys and network adjustments, and you name it, it can do it. But it's all going to be sitting there. But you will and probably will have to tweak some of those settings depending upon what results you get out. So our Travis network scenario, we here in Macquarie Park, which is where I'm located today, we have a small little field that was really good for performing a little bit of a survey. So down Fontenoy Road, back across to Rogel, up to the north, and then sort of close it back off. I didn't do very well as a surveyor because I've set 180 degrees out when I've started my survey from PGO 1 to 1, so everything's 180 degrees. Well done to me. Everyone else who's a surveyor is having a bit of a giggle at me, I'm sure. So the survey was done with an S5 3-second total station with a mini prism only. I want to do the survey to try and introduce as much error as possible, and when we start looking at the results, you'll sort of be able to see where some of the errors might be or errors aren't. So we'll have a bit of a squeeze at that and see what we've come up with. Obviously, angular accuracy is 3 seconds. Distance accuracy is 1 millimeter plus 2 parts per million. So we're pretty happy with the EDM side of it. So we'll see how we sort of go and go from there. So I wanted to sort of just give you a bit of screenshots of our project settings that we'd sort of be wanting to look at. Now, this is very much horses for courses, and really does depend on how your survey instrument is set up and how your office software is set up. Now, your standard errors that are shown on the left-hand side of the screen at the moment. Your instrument can be pre-set up within your survey styles and in your settings of your Trimble Access controller. You can have that stuff already set up, pre-done. You know it's a 3-second jigger. You can set up your errors in centering, your error in your standard other standard errors are all based off what comes in from the total station observations in your .job file. At the same time as you can set it to what I have currently presented as a project settings only, and it'll be based off the settings set in the standard deviation or the standard errors section in your total stations, which is set below it, which is to the right hand side of the screen. Now, I myself like to have more control over it, so I'll like to set everything based on the project settings in the project, and I can then have a bit more handle on the actual survey itself, on the results, how things are tweaking. I can tweak the angular distances, the angular horizontal and vertical angles to sort of suit what I want to see, which I might get through in the weighting side of it later on. It's sort of, horses for courses. Some people like to have it set instrument. I like to do it with project. I like a little bit more control over it instead of what might be preset by somebody else. At the same time, if you go through level, photogrammetry, GNSS, azimuth, they will all be set. You can then set all of those as well to whatever values you want. You might have a set that you need to have. Go through, tweak them. I know TMR have a really good little manual that they've prepared that has all the different values that they will use for doing what they need to do. So TMR is the Queensland main roads. So if you've got something you have a bit of a squiz, search the internet, that stuff's out there. If you're sort of interested in knowing what some of those authorities are using for these sorts of things. Now moving again through the project settings, we sort of jump back up in our tab to the computations. Now looking at mean angles and traverses, this is more what we presented and what's flagged in TBC when you initially start it, load the data in, and it'll flag anything that's sort of outside these values and these tolerances from anything else that's sort of computed. So these mean turned angles are not, they're actually physically turned angles and then calculated from all those observations when it's loaded in to TBC. And again, we'll show you that. Right hand side of the screen, our project settings for Travis. I've left these as default. I haven't tweaked them. It's really up to you and again, your settings and where you are in relation to the world. It could be that you're in New South Wales and you've got our settings here that's set by our survey regs in 2017, or it could be that you're in Victoria and you've got another thing, or you're in Germany, for instance, and again, there's a different value that's set by your authority that you would sort of have to follow against when you're doing your traverses and what you want to see when you're reporting that data. So moving forward now to the network adjustment side of things, that's a little bit further down in the tab. A couple of changes here that I will note. I myself run with include side shots into my network adjustment because I want to actually adjust out all those side shots at the same time as I also want to add in that I may have shot to, for instance, an SSM, which is our state survey mark here in Sydney or in New South Wales. I might have shot to it. I couldn't traverse to it. I couldn't actually get direct traverse to it, so I've just turned it in, and I may have done it from 2 different stations. So I want to add side shots like that in because it's not actually a traverse point. And for instance, I may actually hold one of them as my fixed point and give it a standard deviation. So on and so forth is how I'm feeling related to that. Further down in the terrestrial tab, mean angles. Now this can be set to using mean angles observations, or you can set it to using individual observations. The big difference here would be when the network adjustment goes through and runs the data, the mean angles will be, if it's got it set to mean angles, it will only use the mean angles for calculation of your network adjustment. I would like to see all of the observations and how they all fall out, and it could be that there might be one in there that is flagged as being an outlier. So if you've obviously turned 6 rounds, if you're an RMS surveyor here in New South Wales, you might turn 6 rounds to everything, and you'll, for instance, want to you might want to throw one of those rounds out because it, it's throwing everything else out of the ballpark. So you might tweak that, and then it'll help your adjustment in the statistics down the other end. Right hand side of the screen, we're looking at our convergence display. So this is just the display of how everything's going to be set up when you look at it. So I've set it to parts per million, and then I've also got it set to the Canadian propagation of error. There's a whole bunch of other settings in there. It's again horses for courses and what you want to see, but I'll sort of show you what that looks like as we move on forward. And then obviously our very important confidence interval. This is set down in our standard errors section of our project settings, and we can set it to obviously 99% or a 1 sigma. We just run with 95% confidence interval because that is the standard, the minimum that we're sort of needing here in New South Wales. So I'll leave that as the setting. Okay, well, that comes to the end of the actual PowerPoint side of things. Let's jump into a little bit of Trimble Business Centre. So up on your screen at the moment, you should be seeing a Travis network, very similar to what you saw in one of the previous slides. Something to as we spoke about earlier, was some of the flags. So down the bottom of the screen at the moment, if you can't see it or don't know where to find it, there's a little icon down in the toolbar down the bottom. It's called the flag pane icon. Click that on, and you'll be able to see any of the flags that are presented on the screen in your plan view, at the same time as a bit of information about what some of them are. Now, in our project settings earlier, I set that our mean turned angle, horizontal and vertical, was 3 seconds, and you can see there that it started to throw out some that have a little bit higher than 3 seconds. Again, for my network adjustment, I'm not going to use that information. I'm going to use individual obs anyway, but for our Travis adjustment, it will use the MTA data. So you can see some of the 5 seconds, 3 seconds. I can go through and change those settings and make those flags go away at the same time as you can just turn them off. You don't need to do anything with them. They're only there to tell you that there might be something that's not 100% kosher with the settings you've preset up. Okay, so that's the flags. Points. Now we can see, obviously we have a whole bunch of points. Some are actual points which have been keyed in, and then some are just observation points, these smaller ones around the outside, just the observation points. We have our radial lines or observation lines, total station observations, which you can see here, shown in green and then dark green for the single ob, down there back to PGO1. If you want to see the direction of travel arrows or the direction of the observation, you can go and change that through your program settings. Program options. It's in there. You can set it to being able to see those values if you would like to do that. Okay, now just a little side note, just so that don't get confused. These little lines, these observation lines, they're not actually a line that you can export. It's just an observation line that you can switch off in your view filter, and it's just showing you the raw observations. So if you click on one of them and view the total station observation, it'll show you some of your observed data, what the horizontal angle circle reading was, the vertical circle reading. So obviously this is a face right ob. Slope distance raw, there's your face right confirmation, what I was sighting, and then it's obviously computed horizontal angle, its azimuth, and going forward from there with all the other computed data. Now that's just for the observation itself, and it's not an adjusted data. So if we go back and look at this later on, after we've done our network adjustment, these values will still be the same. They won't change, but the values between the points when computing using a measure function or an inverse function, they will be different because they'll be based off coordinates. So I just wanted to bring that up because that came up as one of our questions last time we ran this session. I just wanted to make sure that everyone sort of gets that and knows that. The observations that you see on the screen at the moment are based all off one point at the moment. So this point here, PGO1, which is my starting station, it actually has in the project. So if I go through in our project explorer and I have a look at that point, I will be able to see that that point was the first station and it has an editable eastings, northings, and elevation. PGO8 for some reason is also the same, and it's probably the fact that I've called it from a file as I've gone and done my survey. So it's called that one up and given it the same value. You can also view that information in the total station editor. Go through total station and then click the .job file that you had, and then for instance if I go into here, it is here, that's my starting station, and again you go back through and have a look at that stuff's fixed. You won't be able to observe that, but then here's all your obs that were completed. So if you ever need to sort of go back through and look at your job, that's another way of doing it. There's your target height. You can see I was running at a weird target height with a weird little mini prism, so again that's another place to sort of find some of your data and sort of how it's fixed. All the other points, if I deleted for instance PGO1 now, the only thing left on the screen will be PGO8. Everything else will disappear because it's all based off that one. So if I just go and delete it, you'll also see those obs. If I refresh and rerun, as you see, everything's gone. It's all based off that one point. So as we go through and run our calcs, we can then pull out some of that data and store it somewhere else, and then you can then go and for instance save this somewhere else and then run it into another job or send it out to your controllers or whatever else you need to do. All right, let's moving forward. Let's have a quick squeeze at the Travis adjustment. So if we go to our standard home tab, has all our normal home functions. Next to that we have survey, and in our survey tab we have all in our optical section we have adjust Travis. So if you click adjust Travis, it'll come up with the adjust Travis pane. To be able to start a Travis, we have to give it a name, and in this case I'm going to call it Travis 1, and I'm going to click create. TBC will be able to read in the data from that one.job file and give you a list of options that could be your starting station. Now in this case, the only option that I have for my starting station was station 1 and how I've done the survey. So I've started on station 1, I've sighted 2 to the backside of 1, and then I've turned in station PGO2, and then likewise started at 2, backsighted PGO1, turned PGO3, and sort of went on from there. So there's no real way of being able to go and start on, for instance, PGO8, and I want to traverse from there. No, you have to sort of start from where you sort of started from. So your traverse methodology in the field is crucial to being able to make sure that this will work when you come in and do this. So old school traversing conventions will still need to be applied when performing these traverses. So our starting station was 1, and we know that. So we're going to click the little blue tab off to the right hand side, and that will then lock that in as station. And then we've gone from there. Okay, where have we gone to? PGO2. I've done that. Yes, that's correct. You then click the add button to the right hand side. It then adds that through. It'll then start linking them together with a red line, and I'll start to draw this around the entire traverse as we move forward. So if I, for instance, said, yeah, PGO3, I'm happy with that. Yes, that's definitely where I went. I want to go that way. It then will autofill and understand how I've done the survey and what I've done and when. And then it'll go, okay, what do you want to do now? Which observation do you want to use? Now, the observations, I've actually gone out there, and when I did the survey, I stored multiple points just so I could have a difference between the two. And in a different part of the training modules, we have looked at the misclose that I got between those points. For instance, on one I got 8 millimeters, and then my closing line between PGO 1 and 1 was 8 seconds. So I've merged them together, and now it's looking at which station line do I want to use? Do I want to use the S9 or the S10 observation line? Now these two are practically the same, so I'm just going to use S9 and then I click add, and what it's going to do is just add that data in, and it's finished off the Travis. Now, obviously, nothing else, no other data, no other way of going. There's only one loop there, and that's all we can do. From there, we move further down and we look at how our single backsite sort of works. What did we use? We can say what are set as our backsite. So do we want to use 1 or do we want to use 2? Set 1, I know that's 0. Ending station, what's the ending station? It is back to 1 again, and we know that's meant to be 180 degrees, so we leave that data in there. Now in our settings, this is the important part, how the adjustment's actually going to be performed. The adjusting angles, now we can have it set to 3 options, no adjustment at all. We want to keep them as they are. We're happy with the angles we turned. We can have it set to an equal proportioning, whereas every angle through the entire Travis will be provided with the same amount of error depending upon their degree and distance and so on. Or we can have it set to a proportional to distance. So, obviously if I've got 3 seconds, let's make it a little bit larger. Let's say I've got 1 minute, obviously over 100, I've got 30 mil, over a kilometer, 300 mil, like, do I want to make that proportional or not? That's where you would set the proportional to distance. I myself run proportional to distance because I don't want to propagate error out, and I don't want to apply the same equal angle adjustment to everything. So I run through that. Same with the vertical, I want to do the same thing. Now, adjusting the horizontal position and the horizontal distance or the distances, this will look at whether or not you want to apply and say that the angles are actually greater than the distances. So transit looks at whether or not you want to say that the angles are actually better than the distances. So we'll adopt them first and then we'll sort of adjust everything out a little bit later. Or you can do compass about it and say, well, no, they both are actually about the same and they're fairly consistent. So we'll look at them as a whole and deal with that. So again, I know that nowadays we can measure quite well with these new EDMs. I wouldn't say that we can measure angles better than distances nowadays. It's actually the other way around. We measure distances better than we can measure angles. So I'll keep that at Bowditch and have the distances adjusted as they need to be. Modes, adjusting manually or have it automatically. So as you change things through the project, the ways you change things through the .job or the total station editor, you can have it automatically adjust the data back out, or you can have it only manual. So in this case, leave it as manual. I would leave it as manual because when I complete something, I know that it's there and it's fixed and it's never going to change, and that I physically will have to change it. You don't want to have to go out there and you tweak something accidentally and the whole lot moves. So yeah, and then do I want to enable the Travis or not? You can say yes or no. Enabling it will show up with the Travis as a purple loop, whereas disabling it will still perform the Travis. It'll still create the Travis, but it'll turn it off, and you won't be able to see it as that loop. But we'll 6 one after the other. In the end, I'll disable it before I perform the next part. So, and I'll just click apply. Now, before I click apply, I could have come up here and gone to preview results. Now this is a look at how the project's actually going to fall out, how everything's done. Now how have I done it? How do I want my settings to be set up? What my stationing, and before the adjustment, what I got. So I got 10 seconds, and my eastings and northings were 11 by 3. So yeah, it's a fair job. Its horizontal distance is 11 mil. There's all my positioning. So after the angle adjustment, how things fall out. So eastings, northings, and I've got 9 mil now after the angles. So I did pretty well on the angles. And then after the distancing, and how it sort of falls out. Now, I've already clicked apply, so that's already in there and it's already applied. You can come up to the top of your pane and you'll have disable Travis, or you can go to your Travis adjustment report. If you click your Travis adjustment report, a new window will open, and you will see some pre-fill information. So obviously I've got a whole bunch in my template already of where I am and who I am. And as we move sort of further down through the adjustment report, we look at, again, those same information we're seeing in the preview results. This is just the formal report of the data, horizontal position, before, after. Again, moving through our results, what points were fixed. Obviously point number 1 was fixed, everything else was adjusted from there, and how everything else has sort of fallen out. Vertical adjustment did pretty well, everything down the tail end, PJ 6 and 7, so they moved by 3 mil. So again, not a bad roll. And again, little pretty picture to show you with that loop. Now that's the Travis adjustment, and again, it's one loop at a time, looking at each individual. So if I had a survey that I did back at a previous company, and it was a very large 3 kilometers by 3 kilometer Travis with multiple interlinking Travises between them, and I can tell you it probably would be a little bit of a pain to do it this way, but it can be done. You just have to make sure the Travis methodology is correct to make it work. Now moving forward, let's jump into network adjustments. So I'm just going to close out of that tab and then close out of our report. Our Travis is set up here as our purple loop. The actual points now have been converted from a just a radial based point to, or an observation point based off point PJ01, have actually now been given their own adjusted coordinate point. So that data can then be selected and then exported if you wanted to do what you need to do with it, and moving on from there. All right, so let's move on to our network adjustment. I'll just go into Travis Networks and disable. Okay, so you see everything's sort of reverted back to the way it was before we started. So again, in our survey tab, if we move further along into the next grouping, we have our network and we have adjust network. So you click that, it'll open up, and we'll see that we have 2 little tabs at the top, constraints and weightings. Both of them will be empty at the moment, and then at the bottom we have our azimuth constraint and our horizontal distance constraint if you wanted to add one of them. To create a fixed coordinate, you need to have your survey points as a survey control quality point before it will be able to be auto-filled into the fixed coordinate section. So I'm going to go ahead and quickly do that for PGO1. I'm going to select that point. You can create a new and add a new coordinate if you want and just change it, change the weightings, or you can go into your grid, so go into your actual point, find your point, go to your eastings and northings, and then change it out through here. So this here will be our control quality for, and mapping quality if you've gone out and done some mapping work, but we'll set it all to control, and there it is. And you can see it's automatically appeared in our fixed coordinates. So I wanted to perform a minimally constrained Travis. I'm not going to constrain anything off to other than this one point, because I want to see how everything else falls out initially before I add any other points in there. So obviously I've fixed one point. I want to fix it in our 2-dimensional space and also with an elevation. Now, if you had some GNSS data, you can set ellipsoidal height as your fixed your fixed value. But in this case, I've only got your elevation, so that's all I've done. Now, because I'm only fixing 1 point, and I don't want it to sort of swing around left and right from that 1 point, I can tell it that I want to have up the page to PJ01. I'm going to set that as my azimuth constraint. This is just one way of doing it. So, for instance, set my azimuth constraint. You can physically select it on the screen if you want, and it autofills, or you can type it in, and then it will automatically pre-fill the value between those 2 points. Okay. Now, the first thing I'm going to do is go ahead and click adjust. The next window that pops up is just asking you about those flags. Now, have you seen them? Do you know about them? Yes, no. And do you want to resolve them? Currently, they're unresolved because I've done nothing with them, but at the same time, I'm happy with their results. So I'm not going to change them. You click yes. And it's come through and it's already passed. Now, that's because the information that I provided, the project settings, sits with the actual observations and the reliability of the observations. Now, I will go and make this fail in a second and show you what that would look like. But so here we've already passed. We've got 94 degrees of freedom, so a few redundancies there, and I've got a reference factor of 0.96. So I still have overstated or understated. I've understated what the statistics would be for this. So for a S5 Travis with a mini prism and just a regular tape, I'm pretty happy with those results. So I'm happy that I've been able to sit that. So let's go through and now make this thing fail, and so you can see what it looks like. So the top of your actual adjust pane, you have the little cog, which will take you to your project settings. Total station, so this is these settings that I set originally, horizontal angle of 3 and vertical angle of 3 seconds, and then my 1/2. So let's blow this down to 1 second, and so I'm going to constrain it further and say that I've measured better than I actually, well, the instrument measured better than it actually does, and I'll leave that as the same. Their instrument centering and so on, you can again blow that out, and I could say that my instrument setting was at 3 mil. That will also make my reference factor go up. So it sort of depends on what you're setting. So you may have to tweak and do a few iterations of being able to work out what might be the best thing to look at. But in this case, we'll just sort of blow out our angles and sort of show you what it looks like. So I click OK and then click readjust. Yes. It'll go through and it's still passed. Oh, well, I'll go even further then. I will blow these out. And click OK. Adjust. Okay, there we go. So I've made it fail, and you can see the reference factor is now jumped down to 0.71. So it's actually gone down, saying that I've again understated the values, and it comes up with that. If you click the little button at the top of your screen or top of the tab, you can go into the adjustment report and sort of have a look at how it's done the adjustment. And just quickly filtering through this. So this is just the settings that were pre-set up in the project settings, the statistics and how it's sort of gone through and done it. So our a priori scale factor, which is the scalar applied after. We haven't changed that. We haven't done that. I'll show you that in a second. How much our redundancies are for each one of those, and then what our reference factors were for our horizontal angle obs. So again, I've done much better than I thought I would have. The vertical angles, they've blown out a little, so I could say that I've done haven't done as well there, and so on and so forth. Fixed coordinates, fixed azimuth, what the adjusted grid coordinates would look like, and how much they've all moved by. So you can sort of see down here, 5 has moved by 11 mil to the east, and so on and so forth. Again, move it a little bit further down. We start seeing some of these
so red flagged observations. So you can see here I've got one observation which sits outside the standardized residual of 3, which is sitting at -4. So it's much higher than it needs to be. So that there is obviously red flagged by the program to say, okay, there's something here that's not quite right. Probably find that your observation is a little bit out. So you may have to go back and look at that, tweak it, and disable an observation. Maybe there's one observation there. This observation, for instance, is out, but the one below it, it's still fairly high, but it's not red flagged. I still would be concerned with that value, and it could be how I've done that, Travis. So that's from 4 to 8. So if I click that, and I'm just going to minimize that window now. If I click that, it'll bring up that observation line. Now it's going from one side of the Travis to the other as just a random brace. I can disable that because I've got other redundancies, and then be able to continue on my merry way. So in project settings, it's already selected. You can click disable, keep the adjustment, and sort of keep going through there as they sort of fall out. Going back to having a bit more of a look at these values now. What you're more concerned about would be these values down here, what the actual horizontal angle reading was from one point to the other. So that'll be from your backsite through to the foresight. So you're interested in knowing that these are around the same. You don't want them to be too much higher than what they need to be. So there's only that one observation. Anyway, that's the basis of the network adjustment report. So I'll close that out. Now, because this network adjustment has failed, and I'm, the values that I've set, I say I'm confident with them. I know that the standard errors are correct, and my centering was I'm happy with it. You can then go back through and then apply the a priori scalar in the weighting section. So this is, for those least squares nerds, you'd be looking at applying that weighted G value across the matrix. So you're applying that scalar matrix in there. So what we're looking for here is which has the highest reference factor. So we're looking at, for instance, your vertical angle has the highest reference factor, and then which one has the highest redundancies. So again, in this fact, the vertical angle has 1.05, and then the redundancy being 33.98. I will, for instance, will go through and then select that one first and click the little star. So this little star here will apply that scalar, multiply that scalar out, and then you click adjust again, and it'll go through and redo the adjustment. And let's have a look at our results. Still failed. We've still blown it out. So it's going the wrong way. So this is already telling me that I've still got something in my project settings that's still not 100%. I need to fix those settings. So again, if I went back to my weighting and I applied my horizontal angles just for do slope distances. So the next one down in the value 0.47 and then 31 value for redundancy. Click that, adjust, click yes, and then go results. And then we're now going back the other way. Now, that's the process if you had your project settings correct and you knew that they were within where you sort of wanted them to be. Now, ideally a reference factor of greater than 1, so we're looking 1 upwards to 3 to 10 to whatever as a whole number. That would be where you'd be wanting to sort of jump into your weighting and start applying that. Now, if it's below, as we see here, you will want to actually apply it or not apply it and go back to your project settings and have a bit of a look at what you've done. So I'm going to go back into my project settings and I'm going to fix this up so that it comes back to what it needs to be. Say 3, 3, and 1. Oh, actually no, make it 1. That'll be okay. And adjust. Yes. Okay. let's clear these. So if you've gone through and done an adjustment and you want to reset everything up the top, there's a way of resetting all your weightings back to 1. And so I've just clicked applied that, and I'm going to adjust that again and click yes and reprocess it. And this will be where we can sort of see I've passed and I've still understated. But you can then go through and apply these. I wouldn't be applying it. I'm happy with those results and would be willing to sort of move forward on the adjustment. Once you've completed that and you're happy with it, you click OK. Each one of these points now will show up with your error ellipse and everything else, obviously weighting off 1 point higher down on the eastern side. These points have now been provided an adjusted grid coordinate. And again, the delta or the bearing and distance between each one of the points, so for instance PGO4 to PGO7, will vary slightly to the observations that are here in green. So once you finish with those observations, you can then turn them off and don't get confused with the actual obs. Your bearing and distance now is between the point to point. So this is just observation data. You can export this data if you'd like to send it out. And you can go back to your home tab, go to select point, for instance, and be able to export anything that's got horizontal qualities of adjusted and fixed, for instance, and send them out somewhere else. So if you want to do your least squares in one package and then send it off to another program or another project, you can do so by doing this. And you can sort of set up how you want it to be done. Like GigaPy, and I'll export how you want it to be done. So what I'm going to do now is I'm going to stop there. I think I've gone on long enough. And what I might do is pass over to the floor. If there's any questions, if you've got anything you'd like to ask, we can sort of move into looking at some of your questions. So what we might do is just remove. All right, so everyone's unmuted, so if you wanted to have a chat, you can, or if you really want to, you can sort of put a bit of an IM down in the pane. So if anybody wants to type away, they can. So if there's any questions, let us know. Details on the screen if you want to sort of get in contact with us after to sort of see if there's anything I can help you with. All right. Well, looks of it, there's no questions. It looks like people are already signing out. So I might cut it off there. Yeah, please send me an email if you've got any questions, and this video will be posted for up on YouTube for everyone to have a look at. So hope everyone has a good afternoon and a good day.